Good morning, everyone. This is the last day of Zero Build, and we have valuable guests as usual. Today, we're going to talk about the look into the energy efficient buildings and what is awaiting us in the near future. We have Professor Yunus Çengel from Nevada University. We have Professor Hakan Öztop from Fırat University, and we have Dr. Yiğit and Altan from Özyeğin University. And today, we're going to talk about what is waiting for us, where we're headed, and in the framework of EU reforms, increasing the smartness of the buildings and adapting to the current technologies, and even grading of these. Well, these are being legislated, and so are smart buildings going to be efficient buildings, and how their integration to AI going to be, and in the PV selection, what is waiting for us, and in the temperature and about the atmospheric stability, what is waiting for us. We're going to talk about all that. And after these presentations of the speakers, we will have a small Q&A session, and we'll move into the debate session. I'd like to give the floor to Professor Yunus Çengel. Welcome, Professor Çengel. Unmute your mic, please. Good morning. How are you? Thank you. How are you? We're good. I'm good too. You look very energetic. I am in Kuşadası now. Yeah, it's not warm, it's not hot. It's great. For the last 2 years, I've been working on the AI on energy efficiency. I have a lot of questions, but I'll give the floor for the questions to the audience. And now the floor is yours. I shared my screen. I think you have my screen now. Yeah, it's great now. Good morning, everyone. Thank you very much for joining us on this Sunday morning. While people are having a nice breakfast, you are at this scientific meeting, and I'd like to thank you for that. In 25 minutes, I'm going to talk about AI in energy systems. What is its place in energy systems? I'm going to try to draw a framework on that. Looking into the future, this is what we see. These smart systems, you know, this AI is in everything now. So everything is turning smart, and energy is no exception to that, because this AI is kind of a cross-cutting and enabling technology. It is penetrating into everything, and two concepts come to the fore: simplicity and integration. If something is not simple enough, regardless of how good it is, it's not really put into practice. As Da Vinci said, simplicity is the ultimate sophistication. And the most effective and greatest things in the future are going to be integrated in their nature. So we better lay it out that the AI is becoming a new platform. Whatever we do, it is going to have to utilize AI. All the tools and the smart buildings, everything that we use, they are all getting smart, and they're not just getting smart with this deep learning. You know, they have self-learning systems. We use automation, and we use robots ever more. Data and data analytics come to the fore, you know, the management of data and making sense of it and utilizing it. and making profit out of data is an important area. The universities are opening up data analytics departments, so we have to learn these things. The energy efficient materials and AI are, we're going to face them all the time, and everything. It's like we're coming back to square one, and we are rediscovering everything. We're looking into energy management systems. With these systems, it is possible to reduce the energy use to its health. What I said could sound like an exaggeration, but just look into this example. iPhone was a revolution in 2007. What was new in this one? Practically nothing. The only innovation is that it brought together different capabilities of different tools. That is to say, integration. And this shows the power of integration. And another point with the iPhone is its simplicity. It's one of its virtue. And once you put together integration with simplicity, it creates great power. Let's move on with a small example of integration. The car that you see doesn't really look that beautiful, by the way. And it's an electric vehicle. It's photovoltaic. It it has solar cells on top of its body. So you put together solar panels with photovoltaic cells, and this is integration. Once you leave this car under the sun, it goes 45 kilometers. But for this to be successful, it has to be appealing in terms of its looks. You wouldn't really buy an ugly car to go 45 kilometers for free. Another field is medicine. Medicine has a very intense training, and with this radiology software developed by Google, it identifies cancer better than doctors, and they have a much higher accuracy rate than human doctors. Is it going to replace doctors then? No, but it is an additional mechanism. If doctor and AI gives the same result, then accuracy rate even increases further. If there's a difference, then there is a need for re-evaluation. So it's not replacing human labor or expertise, but it is making it more accurate. Everyone is talking about self-driving cars and self-flying aircraft. Soon enough, we will have things like that. In the United States, Uber has self-driving cars. They're working on it. They have put them in practice already. Another one is smart factories in the scope of Industry 4.0, a German thing. And, industry is basically moving towards smart systems. Japanese came up with Society 5.0, where everything is smart. Humans cannot be non-smart, so we have to adapt to the change. In World Economic Forum, in 2020, to be compliant with Industry 4.0, we need to have certain skills and capabilities, and these are the best 10 best skills. These things are not really taught at schools: critical thinking, creativity, complex problem solving, people management, coordination with others, emotional intelligence, and so on. These things are not done by the machines, and the AI is not able to do them. So, we are having a kind of a differentiation between what the smart AI does and what humans do. So if you want to accomplish yourself, you have to shy away from the field of the AI and focus on the human issues. So this is American Engineering Association's recommendation of 7 soft skills: communication, presentation, self-confidence, humility, resilience, empathy, and brand identity. This is what you have to have. Looking into energy, when we say energy, smart energy, we say AI plus energy. And you know, there's Industry 4.0. That means the current state of industry plus Internet of Things plus big data plus sensors, data analytics plus and plus and plus. So once you put all of them together, it makes Industry 4.0. So what is Energy 4.0 then? It is basically current state of energy plus Internet of Things plus big data plus smart sensors plus data analytics plus mobile devices, robots, and so on. Interfaces are also important. You know, machines are talking to each other now. Machines are talking to the humans now. And of course, deep learning. These things are penetrating into the field of energy. So where is the world in this regard? Let me talk about a US experience. In the Department of Energy in the United States, they were working on what to do with this AI, how to utilize it. And there's a study on that, and they reported to the department. There are 5 recommendations. The capabilities of AI across all departments of energy. That is recommendation 1. 2, it is the data problem. We have the big data and what to do with that, and having an expert workforce doing regulatory functions, and of course cyber security for artificial intelligence. Department of Energy in the United States is prioritizing these recommendations now. In this new economy, data is very important because data is used to identify things, identify problems, and have predictions and solutions. They all rely on data. So it's basically a data-based economy and business that we're having. And in this regard, the role of data scientists is increasing. What we see today is, you know, data storage is not really something difficult in this day and age. And, you know, the data of the whole world is on your fingertips, and you can analyze it very easily. So you have the data from the world, and the machines do not really make sense of them. Making sense of them is a human thing. So we would need analytical tools and expert people to make sense of this data. So collection of data, analysis of data, and converting it into economic value. For example, General Electric collects data from 5,000 power generators, about 200 billion data points, and it wants to detect anomalies. It wants the system to be more reliable and efficient, and for this it uses machine learning and data analytics. Looking into the energy, you know, we have had thermostat for a long time. You know, they are smart tools, but the new ones are very different. The new thermostats, they know your preferences, your habits, and they learn from you, and they get ever more sophisticated. You know, these simple tools of a couple $100, they use AI. Potentially, these windows that you see, they offer 70% energy saving. This system is being tested in Empire State Building, and $2.5 million of savings was made with these smart windows. They basically block heat during the summer, and they work automatically. They are open to human intervention as well, and they do saving. Even more sophisticated systems like HVAC systems are being used as well. You know, let's say you get the information with sensors from different parts of the buildings, and if you're able to treat different parts of the building in different ways, energy saving is it goes up to 40%. And I'm not talking about more isolation, insulation. I'm talking about more usage habits, and this is not really possible for humans to do, but machines do this now. There are simple forms of that. We have motion sensors, we have light sensors, and other things. Utilizing them in certain places could basically automate the system. It's a less sophisticated system, but it is getting more and more sophisticated. And let's look into this example now. It's a project of Australia. They are going to establish 5 kilowatt solar systems on top of 50,000 homes. And 30% of savings were given to the participants. So it is solar. Basically, it is renewable, and it's energy stored, that is to say, energy efficient. So they work together, and it happens through AI. And of course, the business model, this 30%, if you don't give 30% of the saving to the owners, well, you wouldn't have that many participation. The same thing is, it goes with the wind power, working together with the user and operator, how much electricity is going to be used, how much is going to be sold, all of that is being done with artificial intelligence. At homes, normally a battery is enough for 24 hours of consumption of a home, of a house. Alongside, you can store energy at nighttime, which is cheaper, and you can use it in daytime, or you can sell it, basically, and this means new business. The most exciting one is these electric vehicles. You see a car here, but for electric grid, it is a storage system. We're talking about a battery with a huge capacity of storage, so you can use to store and sell electricity, and the system could make these decisions. We will keep seeing these things more and more. Of course, this raises the question of security. I'm talking about cybersecurity here. There was a huge power outage in Ukraine at a vast scale, and it was because of a cyber attack. AI creates danger. Elon Musk basically says that these AI-powered robots are posing existential threats to humanity. Not everyone shares this perspective, but it shows the capacity of AI. A lot of people are concerned whether our jobs are going to be taken by robots. So I say, don't you worry about that. Just be human. Focus on what makes you human. And these things are consciousness, imagination, inspiration, creativity, initiative, and out-of-box thinking. AI doesn't have this and will not have this. I have a paper on that. So, like these things are going to create a consciousness. No, they will not. if you focus on these aspects, that means you're going to be a person that would be looked for in the future. This is Danielle Merfold. She is CTO of General Electric. This is what she thinks about future. Their strategy about energy investment is on these new technologies. You know, these technologies can be implemented in everything. And looking into the integrated systems, you know, what concepts comes to the fore? First of all, that it should be affordable, reliable, accessible, and sustainable. They basically draw the framework of the future energy, and the digital trends of the future break this down into two. The first thing is the control. You know, everything is controlled through software. Everything comes down to the software, so it determines things. The other thing is additive manufacturing. You know, it basically means transiting into new manufacturing, and the digital transformation is expected to be cost-effective, sustainable, and reliable. And once that happens, you know, these concepts they spread into every technology, and they have a transformative power. One last word is that let's just keep in mind that AI is very important. It changes everything. But for institutions and companies, the biggest asset is not AI, it's more like natural intelligence of the humans. So without natural intelligence, artificial intelligence wouldn't do a thing. So if just remove humans from the scene, and AI would do basically nothing. So humans are still at the center of everything. That is all I have to say, and thank you. Thank you very much, Professor. We'll get the questions at last.
So let's keep the questions to the end, and we have to add the empathy to this list, because empathy is something that the artificial intelligence can not actually accomplish. And health sector, which requires human interaction, most probably will not be affected by the artificial intelligence for a long time. In the book of Rise of the Robots by Tom Ford, it is stated that the author states that this is my second book, and the first book of mine was written 9 years ago, and he says that all of my projections turn out to be wrong. So he states that, I mean, many things developed like 2.5 times faster than I projected. And he also adds that gradually we will try to crack and understand the general situation. So what you say is right. Human beings should do what they are capable of. So most probably many of the things will be automated. And one of the main features of being competitive is as follows. Without an automation system, an enterprise will not be able to compete with the global companies. It is not possible in today's world conditions. An enterprise which totally depends on human workforce cannot compete, and they will not be sustainable at any cost. Thank you so much. From Özyeğin University, the Faculty of Construction, I'd like to yield the floor to Dr. Yiğit Altan, and he will deliver a presentation about the changes in the temperatures of the facades of the building due to the changes in the atmospheric layers. Well, first of all, I am so happy to be with you. My Sunday morning couldn't possibly have been better. And we are also very happy that we have the chance to speak out about those issues in such an important forum. Well, most probably together with the Zero Build Forum, for the first time, we have realized that many people enjoyed those meetings because they are unfortunately unaware of what is being done, especially young people. So we shouldn't stop working and we should do our best to improve ourselves. That's why I am certain that what you will deliver as a presentation will be quite appealing for the audience. Hello to all. My name is Yiğit Altan. I am a lecturer in Özyeğin University, the Department of Construction, and my field of interest is the fluid mechanics. And in my presentation, I will speak about the variations at the facade temperature of buildings due to stability of the atmospheric boundary layer. And I will be making use of the fluid mechanics. As the title suggests, I will try to analyze the variations and the changes in the facade temperature of the buildings. Climate change triggers many things. Well, without the climate change, most probably people wouldn't have invested in zero energy buildings, but climate change, as I said, was the triggering factor. Well, I can define climate change as increased occurrence of extreme conditions such as rainfall, floods, heat waves. Very calm and stormy weathers are also observed much more frequently. What kind of a solution can we provide to climate change? First of all, we can design climate-proof cities which can adapt themselves to those changing conditions. And the European Union has a target for 2050. They aim for designing carbon-neutral cities. I am working in the field of urban physics, so I can provide solutions for such problems by urban physics. Well, what is urban physics? It is about modeling of the atmospheric boundary layer for the urban area. If you focus on this red area, you see the turbulences, the thermals, also convections. Well, when I say urban physics, I don't mean such a huge city like Istanbul, but certain districts, for example, like Beşiktaş area might be the focal point of the studies. What do we do? How does that perform? We are resolving mass and energy transfer via CFD simulation and experiments. And today I will cover the topics of urban microclimate and what kind of impacts the heat waves have on the cities. So first of all, we have to ask and understand the basis for zero energy buildings. Zero energy buildings consume less energy, but of course, how should I put it? We can use insulation, thicker insulation layers in order to consume less energy, but we don't have unlimited resources and we should be careful about it. So we should produce and manufacture in an environmentally friendly fashion. How can we consume less, and how can we consume our resources less? We have to model and simulate with realistic environmental conditions. What should we do then? We should understand the characteristics of the weather at extreme cases like heat waves. Heat waves will be the example that I will be analyzing. Heat waves are formed under high pressure and through stable stratification. Two scientists have defined the length scale, which is called Monin-Obukov length scale. As the stable stratification is increasing, it actually accumulates the humidity, and the outer layers will not have that humidity. It will lead to limited mixing length, and this will mean slower wind speed at the lower levels of atmosphere. You can see the impact of heat waves on the graph on the right hand side. You can see that there is actually a 17% of difference between natural wind and stable wind at the latitude of 100 meters. This leads to decreased the pollutant removal. Especially we are warned not to go outside during the high level of air pollution. And another problem is the increase of the heat island effect. Okay, then, what were my research questions? Does stratification affect the facade temperature? This is a very important question, because should we use more insulation properties, or do we over-insulate or under-insulate? So we are understanding the basic characteristics of the building when you find out the facade temperature, and then you can have a better understanding in terms of the thermal performance of the building. For example, we know that we have to insulate slightly more for the northern orientation in this pole, but we should also understand what will be the impact of extra insulation. That's how we will be using our resources much more efficiently. When I take a look at my past studies, I have taken a small box and I have created this heat island area, and the heat flux was 105 watts per square meters. This figure has been in line with the literature, by the way. The length of the heat island was 1000 meters, and the wind speed at 50 meters was 5 meters per second, and the temperature at the ground level was 27 Celsius degree. And based on this analysis and experiments, I understood that as the stability increases, stable L equals 100 meters equals actually shows us a stable situation, but this area from 0 to 50 meters is the area where we live, and we see that the pace of the wind is decreasing. When the environment is very stable, then we will see a higher reduction in the pace of the wind, and it will have a huge impact on the building. And how can we calculate it? I am placing a building along the X axis, and its length is 85 meters, its width is 40 meters, and its height is 35 meters. It is a typical building that we can encounter, and the construction material was concrete, and the thermal conductivity was 1.6 watts per meter Kelvin. And I also implemented heat flux with the value of 105 kilowatts per square meter, which was in parallel with the literature. Then what do? I have a simulation domain. It's an octagonal simulation domain, and each edge is 500 meters. I have the structured mesh of approximately 1.3 million, and I created those 50 layers so that I can find out the temperature surrounding the building much more efficiently. The outside temperature was 27 Celsius degree at the ground level. And there has been different stratification levels like 100 meters, 250, and 500. So rather than implementing wind from only one axis, the wind direction has the oblique axis, and the wind speeds were 2.5, 5, and 7.5 meter per squares, per seconds, I'd like to correct. So I have understood that in very light wind conditions for a single point, I have the highest temperature. The reverse side of the wind, so the southern facade, the average temperature was found out to be much more higher. So rather than taking into consideration the single highest point of temperature, we should take into consideration the dissemination of the heat. So that's why the low levels should be insulated much more efficiently. So we see that the facade, for example, the northern facade will be much more warmer with comparison to southern facade. But as the latitude is increasing, then the temperature where the wind blows will be increasing. Due to the stratification, the heat distribution on the facade will be affected more with comparison to stratification. I mean, maybe it is not easy to see them, but in the upcoming slides, I will present you a chart. As the speed of the wind increases a lot, we see that the stratification effect comes into play. The higher altitudes will be much more cooler. So when I summarize all those analyses in one chart, you see the stratification layers marked with red, and the part which is not marked with red under L500 is the typical conditions that we use for the building analysis. So we can see the differences among those actually levels. Under slow speeds, for example, L250 will present higher results with comparison to L500. So even a slight level of stratification will lead to higher temperature levels. So when we take a closer look at the average of the building, we will see that the 0.5, the neutral conditions will present lower level of differences, we see that the heat transfer is quite slow, and when the speed of the wind increases due to the stratification effect, the heat variations will be increasing. So when you think about L500 or 7.5 meter per second of a wind, it might be thought as the wind which is blowing at the 15th floor of a huge skyscraper. That's why on an average level, the heat distribution will be quite different in different levels. As a conclusion, we can understand that the stratification affects the building facade temperature, and increase in the wind speed will definitely increase the difference between facade temperature at stratified and neutral atmospheric boundary layer conditions. These are really important outputs for us. What should we do as a future study? We should use canopy models. So the buildings will be placed actually one by one, because one building in front of another building will definitely have an impact. We should also include the sun radiation analysis into consideration, and also the building inside desired temperature. We divided this domain into 1.3 million cells, and we should resolve the mesh and use near wall modelings. And we should make use of more simulations so that we can come up with better solutions. Thank you so much for listening to my presentation. Thank you so much. Well, for a very long time, I have attended to the building inspection meetings, because I know that it is really hard to carry out such analysis with different engineers from different countries. We have discussed those issues. I am certain that it's not easy. What you said is quite right. Such kind of scientific studies should be integrated to the legislation and to practical guidelines. Otherwise, it will not be easy to implement them on site, because first it will increase the costs, and the lack of expertise among the practitioners, unfortunately, will keep a blind eye to those issues. Generally, the highest and tallest buildings are constructed in the coastal areas. I have seen in Izmir, for example, I was passing by a very tallest building. It was such a high level of wind effect. A mother, together with her daughter, was actually passing by this building, and all of a sudden, due to the wind effect, the daughter, such a strong wind effect, was almost flying. So I've never encountered such a thing. I mean, the mother was trying to drag the daughter down from the air, so I, of course, rushed to help them. But the effects of such, winds and stratification is observed in our daily lives. Heat island is a huge problem. Unfortunately, we see the squares where there are no birds or children's playing, and their numbers are increasing. So we should have a global approach, and we should make the design from scratch, from the beginning, so that further costs will be prevented, because making the corrections after the construction will be much more harder to be undertaken. Unfortunately, we have to bear all those costs, and I'm not speaking only on behalf of Turkey. Thank you so much. We will take the questions at the end of this session. The last speaker is Hakan Öztop from Fırat University, the Mechanical Engineering Department. In his presentation, he will speak about the shading effect on buildings. I have seen many bad examples on site, so I will be really interested in your speech. Without further ado, I'd like to yield the floor to you. Thank you, Mr. Onur. First of all, I'd like to thank the organizing committee.
Thank you very much for giving me the opportunity to speak here. Professor Çengel touched upon current issues. You know, he said software determines everything. And after 48 years of age, I started my second PhD at my own university, you know, on software myself. So after his presentation, as an academic working on energy issues, I realized that I made a corrective decision starting the PhD on software. And Professor Yiğit also mentioned an important issue. We also have conducted research on that. In my presentation, I am going to talk about photovoltaic panels, an important element of zero energy buildings. And I'd like to tell you about some of our studies. So as you know, photovoltaic panels, they basically started to be used in small implementations, but starting just like in Europe, in Turkey, there is a supporting legislation, and we started seeing these panels more on rooftops. So these panels are also frequently seen in irrigation and pump systems in agriculture. So we see that in terms of percentage, they are low in use. We are talking about various issues. One of the reasons that we're still talking about that is that photovoltaic panels have low efficiency, and field work is still being conducted on that. So, you know, we can say that their efficiency changes between 12 to 17%. We can have very different levels of efficiency, and there are different field practices. You know, even the bird shit could be a problem. They all have a shading effect on photovoltaic panels, and they decrease the efficiency of these panels. In our work, we had some experimental scenarios, and I am going to talk about them right now. I am going to talk about the shading and practice of these panels. One of our studies basically indicated that, especially in rooftop implementations, We are doing that because we don't have enough rooftop areas on top of the buildings, and unfortunately the speaker's microphone is, I think it is rubbing some surface and it is making a lot of noise. Okay, let me move on as much as I can. Photovoltaic cells, you know, they get electricity, they produce electricity not from heat but from the light. So photovoltaic panels, they are used together for, I am sorry, but this is not translatable. The translator does not receive a healthy voice of the speaker. We know that once photovoltaic panels, when they create electricity, they also create heat in the backside, and we have conducted studies on that in Saudi Arabia, and the results indicated that the rear surface heated up to 80 degrees. So when the electric production decreases, the heat production also decreases. And then this basically brings limitations to heating the water. You know, one of our studies basically was based on different geometric scaling, and it was on shading. So we basically focused on snowing and the issue stemming from the shape of the roof. We worked on 3 scenarios, you know, right triangles, isosceles triangles, and different triangles were tried by our study. In another study, horizontally or vertically, you know, shading of the panels, also they have an effect on the efficiency of the panel. For example, we covered some cells, and then we covered the whole under the whole bottom line, and then we covered the upper line. So we basically implemented shading under the same sunlight, and we tested the efficiency of the panels. You know, connection of the modules on the panel, there are some issues about that as well. Once you shade a cell of the panel, you may affect the other cells as well, and this decreases the efficiency significantly. At Fırat University, between 2016 and 2017, we have conducted various studies. We didn't have simulator back in the time. We do have right now. And in our field work and simulation work, you know, they're not always consistent. This is why we thought that it would be more proper to work in the field. And we looked into thermodynamic analyses of the system. You know, the first and second law of thermodynamics was used to conduct analysis, and you know, at different points of the system, we located thermocouples, and we measured temperature at 10 different points, and we created a heat map, and we measured the strength of sunlight, and and we tried to measure the power, and we aimed at showing the effects of shading on these vehicles. So according to first law of thermodynamics, you know, we have conducted energy analyses, and We have also done exergy analysis, and we used the books of Professor Çengel, by the way, for this analysis. And in our exergy analyses, the energy that we get at the output compared to the energy that we have and the input, you know, we try to measure the performance of the vehicle by comparing the input and output. So we used exergy deficiency of Patella equation, and we have done calculations based on that. We selected the value of sunlight from literature, and then if you want to share screen, Professor, we can do that. Can you do that? I sent you my presentation. There is the share screen button. If you click on that, you can share your screen. And then you're going to have to click on the file. Okay, we have the presentation now. So with exergy calculations, we used Patella equations, and we have conducted different scenarios, and we had a chance to work on a variety of scenarios. You know, A1 is SL health covered, A2 is at a different scale, A4 is one cell fully covered, B1 is a horizontal line covered, and C1 is a vertical line covered all together. So we created an artificial shading. So we used simple simple material that are not transparent, and we used solar cells of polycrystal, and we obtained their characteristic from the manufacturing company, and we conducted tests on them. And especially in the electric photovoltaic system, its electric exergy was calculated, and we have calculated the exergy loss of the system, and we considered environmental effect as well. We have put the wind speed, wind velocity into the equation, and there is an equation at the bottom of this page right now that is the most popular equation used in similar studies. And using this equation, we calculated the exergy output using this equation. So, and we basically tried to obtain the efficiency of the system using the second law of thermodynamics. And I'm not going to go into details here. Here, if we don't do any kind of shaving on the cells, this is the graph between current and voltage. So if you see, if it is covered, there's a decline in the current. If you cover one cell altogether, the whole one cell, we see a 50% decrease in the current. So we have to be very careful about that, especially in the solar panels used in the field. recently the automated wash systems have been developed, and this is what we basically recommend, that they should wash the surface of the photovoltaic system once in every 3 or 6 months. So there is a significant decrease in the power output. You see, the same goes on to the rooftop systems. When it happens on the rooftop, it is more difficult for us to intervene. So some shading factors, for example, if a leaf falls onto the surface, we may not even be able to see it. So it is difficult for us to intervene on the rooftops. So the same goes for the water heaters that use solar system. If we don't do something like that, if we don't wash them, clean them, there is a significant decrease in the power output. Normally, without any shading, we used to get, let's say, 50 watts. If one cell is fully covered by shade, the output decreases 20 watts. So we tested different scenarios, and as you see, when we do horizontal shading, when we cover the whole line at horizontal, as we have some effect like that in the snow, for example, once we are placing the panels, we consider that one panel does not really shade the other one. If we don't do that, if we cover the whole horizontal line, we have almost none power production, zero power production. So smart systems started to be developed considering this. There is a project in Gazi Technokent. They created a system. Once the system does not produce electricity, they give you a signal, a system like IoT, and you basically see the problem and try and remove it. In vertical shading, we have a similar output. If you cover one shade, the whole one shade, the power output decreases down to 0. And we have different results depending on the time, depending on the solar radiation, depending on the clouding, or depending on different hours of the day. We have this published, so you can find it in the relevant literature. Other than that, it has effects on emission as well. We have certain results on that as well. And another interesting study on this issue is this one, especially in diagonal shading. Alongside the static results that I shared, we can have we would have dynamic results as well. What are dynamic results? Based on the season or the movement of the sun, let's say you set up the system, but there's a chimney on top of your roof, or there's a next building. Once you establish, you don't have the shade on the solar panel. But depending on the hour of the day or the next building becoming an obstacle to the sunlight, it could have an effect on your solar panel. So it is exposed to shading. We have to take this into account. Otherwise, your investment is a vain effort. Other than that, we followed it up in a dynamic and static manner. We basically erected a column here, and we measured the effect of its shade in different hours of the day. We used a test stand here, and we measured temperature from different points. We followed 3 different scenarios here. We created simple triangles. You know, when there is a diagonal shading affects more than one cell most of the time, and different problems arise from that. The pathway that we followed here is parallel to the previous study, and we used the same equations, and we tried to evaluate the results that we obtained. You know, we used a polycrystalline solar panel, the same panel system that with the previous one, and we tried to evaluate the results. Let me show you some of those results. The effect of the dust was taken into account as well. There's a reference photovoltaic panel. One of the panels was artificially dusted. In the right upper part, we basically placed dust on the PV panel, and if the panel was covered with dust, of course, there's a significant decrease in power. But if the panel is right next to a chimney, there's a much steeper decline in the power output compared to the reference PV. It's basically the default PV that we clean every day. If there's a chimney effect, for example, if you check it 9 or 10 a.m., your panel does not almost create any electricity. That is a vain investment. So this is why, you know, the idea that solar panels basically return the full investment in 6-7 years, well, this full return of the investment is delayed to 10 years in a system like that. So in the off-grid systems and on-grid systems, this situation goes the same. This is showing some results about the fill factor. You see the efficiency. The fill factor is affected by a variety of factors. So the back panel fills create a significant decline, and using the surplus heat, you know, the temperature increase at the back side of the panel. If you compare it to the reference panel, you see the environment temperature as well. You know, especially in dust and other effects of the solar PV, the back panel temperature has risen. So this is our visual from a thermal camera, and there we have some hot areas here, and you see the shaded side here. You know, these panels could be burned easily, especially with hotspot effect. You know, sometimes one full cell is out of use, and effect of such shading, our studies were supported by Bob and Tibitak, and I'd like to thank them. This is all I have to say on the issue. If you have questions, we can always go back to the relevant slides and I can get questions and I'll try to answer them. Thank you once again. Thank you, Professor. So let me ask the questions.
For example, on our site inspections in terms of the energy efficiency, when we go to the roof, we see quite different situations. For example, the elevator towers. They constructed a building, but at the middle of it, we see an elevator buildings, and it provides different level of shadings on the system, and nobody is satisfied with it. But there is nothing else we can do because the roof area is, clear, and the elevator tower has been constructed before everything. So my question is as follows: when exactly should we do the planning? Because another building might be constructed next to your building, which you cannot know in advance. Well, on that regard, the architects should also play an important role. If there is an elevator on the building, then the elevator tower will be inevitable. So maybe we can, follow up the building. Those systems are still quite expensive, and we can do inspections from time to time. And if there is a system which will totally shade your roof, then it's a different situation, because we see a building with 4 floors, and next to it there is a building of 8 stories, for example, 8 floors. So we should really think about them in advance, because we have seen the impacts of the shading, and we should really be careful about those aspects. Or with a more expensive investment, there might be systems which can follow the sunlight, but it will, bring along the effects of the wind and extra cost, of course. The PV panels might be much more advantageous for on-grid systems, but their impacts will be slightly lower. But anyhow, they might bring along certain advantages. Do you think thin film technology might be a solution? Selenium, carbon-bromide, thin film technologies, what would you like to say about them? Yes, we can think about those thin film technologies, but at the end of the day, we should take into consideration the final costs and the recycling future. Transparent panels and flexible panels come into play in our lives. And let me give you an example from my own university. We have the 5th biggest closed area sport hall, but it has an inclination, and placing panels will be extra cost and extra construction. So if the flexible panels might be considered for that area, such kind of buildings will be used much more efficiently. But of course, at the end of the day, we should take into consideration the costs. Thank you so much, dear professor. Thank you so much for your speech. I would like to turn back to Professor Yiğit. Professor, once again, thank you so much for your presentation. You have enlightened us about the importance of heat islands. Most probably in post-COVID-19, these issues will be much more important. Do you think that we can integrate those systems to the healthcare services so that the awareness will be increasing? Because I am observing that the municipalities have already set forth such commissions, and those commissions are making the preliminary studies to what to do. And they prepare strategic papers and roadmaps for the mayors. Do you think that we can have a say, we can say something to them? What would you like to recommend? As far as I understand from what you mean, you are saying that we should prevent the closure of a building by another building. Well, there are ongoing studies, for example, in order to open the sport halls and gyms, for example. We are aiming to prevent the aerosols being produced, and we should do those CFD modelings and simulations so that the fresh and healthy air might be obtained for this closed door area. But of course, the right modeling and the simulations should be done. We can resolve those models, of course. We might use it for COVID-19, or in general, we can use those models and simulations for providing the healthy and fresh air to the indoor areas. So do you think that the municipalities should cooperate with the universities, because that technical capacity might be lacking in the local companies? Well, those modelings require some time, and when you go to the market, you may not be able to find the optimum solution. Well, CFD is like actually a sharp blade. On one side, it can cut the deal, but on the other side, you can cut yourself with it. So it requires meticulous study, and allocating the time and budget for the university for the CFD studies and simulations. I do believe the results will be much more beneficial and healthier. Well, Professor, then let me ask you this question. In order to prevent the stratification, do you think that we might add certain recommendations to the legislation? Well, maybe I mispresented it. We cannot prevent the stratification, but we can take into consideration the temperature variations due to stratification. I mean, we should understand, for example, what will be the temperature. If it is 36 Celsius degree, then what kind of an insulation method we will be using should be the approach. I have an ongoing project, for example. I am, preparing certain geometric drafts to be used practically in the future. Well, if we can do the deduction of simplifying those into geometric shapes, hopefully people will benefit from them. I have an ongoing Turkish Scientific Institute study. Do you need open data for such studies? Because the first speaker spoke about the importance of data. Do you think and do you need open database in your project? Well, at the moment we don't need it, but when we go on site for making assessments, then people are questioning, why do we do such kind of analysis and measurements? We do it in our university, but when we go to the city and try to do the assessments and do the measurements, we have to take the permission, and sometimes it is becoming quite troublesome. We can take those data from the meteorology, but the latitude and the height of the buildings might be quite different, because we need the height, width, and length data of the buildings. And if people support us for collecting those data, our studies and the burden of our studies will be eased. And when we have to, do such kind of measurements inside of the buildings, then from time to time problems occur. On that regard, they can help us. Thank you so much, Professor. So I'll have questions for Professor Yunus. But first and foremost, I would like to state that in your presentation, there was a very important observance: data. You have underlined the importance of data. If I'm not mistaken, 4 gigabytes of sensor data is being recorded for the autonomous vehicle. Companies are criticizing that we are losing data. They have sensors, but were you able to check what is the amount of data that you actually recorded? And sometimes we have seen that, you know, they place the sensors, but the hard drive of the computer is full, and the computer gave the warning notification because there is no empty space in the hard drive. That's why they cannot record the data. But I am also sure that certain companies can only record data with the size of 1 gigabyte, which is way less than the autonomous vehicle data record. So I'm not sure whether it will be enough for those companies, but in the field of energy, I don't think that the data losses are so high. And do you think that there is a margin which we can improve? Well, it's all about being serious. I mean, if you take a glimpse to GE, you will realize that they are collecting millions and billions of bits of data, and they are using it. But collecting data shouldn't be the ultimate target. You can collect the data and store it, and you can say that we have all the data in the world, but you should be processing the data. I mean, if you have one bag of fig in your hand, if you are not using it, then it will be useless. Well, collecting data is important, but without data analytics, those collected data will be meaningless. And by making use of the artificial intelligence, you should find out the meaningful data out of that data collection. And from those meanings, the human beings should take action. After you are collecting the data clusters will be formed, and you should be able to use it somehow, because data on its own is nothing. Data analysis and the data analytic tools are really important. We should be collecting data and taking meaning out of it, and we should turn that data into economic benefits. Other than that, otherwise you can collect all the data in the world, but nothing fruitful will come out of it. Well, people were saying that the artificial intelligence is the new electricity because it is changing all the sectors. When you combine those techniques with 3D printing, it will definitely change all these sectors. If I'm not mistaken, it was about the hearing aid devices sector. Well, within 3 months of a time frame, thanks to the digital technology, the 80% of the whole sector has been changed because they are doing the mass production for the hearing aid devices. So I don't think that it will be impossible for other sectors not to be changed. So I do believe we should shape our enterprises from scratch so that the artificial intelligence is integrated into their production, into their marketing and sales processes. I do believe this is what the enterprises should do at the moment, because do you see such kind of a transformation in the energy sector? What would you like to say about that? Well, in terms of energy distribution, production, I am asking this question for all the parts of energy sector. When it comes to the production of the devices, if there is mass production, then it will be much more cheaper. But hearing aid devices example was quite an interesting example, because the hearing aid devices should be adaptive to the ear anatomy, and producing those hearing aid devices with the 3D printing will be quite a rational choice. And when it comes to the energy sector, this will be the case. I mean, the 3D manufacturing will be a new mode of production, and everybody should plan their futures accordingly. Maybe at the moment we will continue with the conventional manufacturing techniques, but this additive manufacturing and 3D manufacturing will be the new reality of the future. And the artificial intelligence, the software part, will be the core of this mode of production. You will collect your materials, and then the rest will be done by the software. So without artificial intelligence, the 3D manufacturing cannot be a reality, but artificial intelligence is just one of the applications that it uses. And we speak about smart grids. In the future, most probably, we will see the following scenario. The electrical vehicles will turn into devices, even the refrigerators and the air conditioners will be communicating with each other. So, I mean, if they are giving us like 5 Turkish lira extra, we will give the commands remotely to close our air conditioners. I mean, all of those data at the end of the day will be processed by the artificial intelligence, and it will be managed by the artificial intelligence, and the reports will be produced out of those consumption and usage behaviors. And from the point of electricity consumption to the pricing of the production to the supply and demand balances, everything will be done by the artificial intelligence, and most of the time human beings will not be intervening with it. You will just set forth the rules, and when there is a need for a change in the rules, the system will be automatically adapt to those new rules, because human beings cannot have such level of a pace. So people cannot do this. In the field of energy sector, these technologies are partially implemented, but after 3 or 5 years, we will see whether its intensity will be increasing or not. We cannot escape from it. I have a TÜBİTAK, Turkish Scientific Institute, project ongoing. That's why I am following those developments, both the European legislation and the American legislation. And it is a must to integrate the users to the system. It is not a choice. So in the changing environment of the energy sector, we will be dealing with much more devices, and the generators will be integrated and will correspond to the demands of the users. The legislation studies have been ongoing, but most probably it slowed down during the COVID-19 pandemic, but it will be a reality in Turkey as well. Europe is not like USA, and they are just, following from behind. The main reason is that they are not giving permission to the independent demand collectors. So the demand collection is done by the general electricity generation companies. Finland gave that permission, which is a very nice example. Thank you so much, Professor, Mr. Hakan, Mr. Yiğit. Thank you so much for your speeches. We have come to the end of our session. It was a very enlightening and very enjoying session. I hope this is the case for our audience. Hope to see you again. Goodbye.